Everyone, good evening. Thank you for joining. So today I thought we'll go through the most elementary concepts of programming, and hopefully this is the first of a series, so this will be a little more fundamental and we'll build on more concepts as we go along. I have no definite plan of what I wish to do, but as we go along, let's figure out how we would like to go in. So now before we go into programming, let's ask ourselves a simple question. Why would we even want something such as programming?
To communicate with a machine, computer.
Okay. Now, why would you want to communicate with a machine?
To create systems and frameworks.
Okay.
Machine is faster than us in computing certain things. Like
Exactly. So the earliest motivation was possibly something like that, right? That you want to carry out some calculations, and now if a calculator can carry out the calculations, why do you want programming? You have a calculator anyway to do calculations, right?
calculator can't perform complex mathematical problems, just simple addition, subtraction.
No, scientific calculator can, no?
That
Trigonometry.
is restricted to like logarithm and like certain functions only. Again,
So, I mean, you see two motivations, right? One is, what if I want to repeat the same thing again and again? In a calculator, I'll have to manually instruct it. Second, what if I have a series of instructions which I want the calculator to do? And I'll have to manually wait for that calculator to do it again and again, right? Isn't that a little problematic? So it makes sense for us to have a mechanism where I can tell a computer that, hey, these are the things I want you to do. And the computer does that for you. So what are you trying to make? You're trying to make a system where you can tell a computer, I want you to repeat this again and again. And you also want to be able to tell a computer a complex mechanism which the computer can sort of use. Now, let us say Rishabh asked me a problem. I use a method to solve Rishabh's problem. Now, Jay asked me another problem. I use the same method slightly differently to solve Jay's problem. And Sherin asked me another problem, and I use the same approach again slightly differently to solve Sherin's approach. Now, do you want me to tell the computer the same instruction for three of them? Or do you want me to tell the computer three different instructions for three of them?
If a problem solves with the same method, so
I mean, you love a reusable method, right?
yes,
I would use the same method, but giving some conditions. If this condition, this happens. If this condition, this happens.
Correct. So you'd probably love to have a method which applies in different scenarios. Like instead of making a separate potato peeler, separate carrot peeler, you'd want to have one single peeler which can peel different vegetables, right? So which then means that while we are trying to design our programming language, we want this language to be able to express such complicated logic. Where the logic is complicated because even if the situation changes, the logic doesn't change. So we would want a programming language to be equipped in that way, right? Now, we spoke of two requirements, right? What is the first requirement? The easier requirement. What is the easier requirement? Something which a calculator could not do, or a calculator could do.
automatic.
Yeah, repeating it again and again, right? And what is the second requirement? This performing complex steps. Now we'll come to second requirement in a while. But first, let's understand, do we want a program to be able to do the things that a calculator also can do? That's a base, right? It builds on those basic steps. So which means we want a program to be able to store information, and we want a program to be able to perform calculations on that information. Makes sense? So now if you want a program to store information, you need access to memory. Now, are all information of the same kind? No, right?
No.
What are the different kinds of information that you could have?
Could be a character, could be.
You could have words and you could have numbers.
Yeah, different data types.
Yeah, I mean, let's not use the word data types.
Oh.
We're trying to have a Socratic way of investigating the fundamentals. So now, what did we say? We said we want to build something more powerful than a calculator. But if you want to build something more powerful than a calculator, it starts with being a calculator. Now, if it starts with being a calculator, you want this fellow to remember stuff. Now, when this fellow has to remember stuff, the kind of stuff this fellow has to remember can be of different kinds, right? So one kind is this fellow could be remembering names, which are not numbers. Now, even within numbers, does this fellow remember different kinds of numbers? Okay, for a human being, 5.0 and 5, are they the same or are they different?
Same,
For a computer,
Different.
different.
why?
One is integer, second is float.
To identify,
That's Ramalingam answer. Why is it right? Why is 5 and 5.0? Why are they different for a computer?
Because when computer is analyzing that 5.0, it is basically considering three how can I say, uh, basically it is considering three elements, but when we're just writing 5, it is considering just one element.
Okay.
Computer is reading the whole set, and we take it as a logical thing, like just randomly take the number out of it, not the analysis out of it.
Yeah. So how we do it, why we do it is still a mystery. We're still trying to understand the brain. So which is why I think the good news is we're probably nowhere close to replacing our brain with an AI, because we ourselves don't understand it to replace it. But yeah, now if you understand it from a computer's perspective, think of it. Don't you have to train the computer to remember to understand numbers? Now, when you're training a computer to understand 5 or to understand 8, you're telling a computer, okay, now forget how a computer understands numbers. You know how a mathematician understands numbers? What is a mathematician's definition of 0? A mathematician's definition of 0 is the cardinality of null set. The number of fellows in a null set is a computer scientist definition of 0. What is 1?
True.
The cardinality of power set of null set. What's the power set of null set? That set which contains all the elements of the null set. So number of elements in the power set of null set is 1 for a computer scientist. What is 2? The cardinality of power set of null set. What is 4? The cardinality of power set of null set. Okay. So this is how we human beings, I mean, the ones who study mathematics, understand numbers. But the way we understand decimals is very different from the way we understand integers. So the representation changes. It's not just the representation, but the processing itself changes, right? Now, if I give you 2 decimals and I let you divide decimals, then suddenly the number of things after the decimal I'll have to accommodate more, right? So the way I handle a decimal and the way I handle an integer is not the same. Handling integers is tougher. If I design my computer to handle those tougher situations, okay, let's put it this way. You have a small paper cutter and you have the bigger paper cutter, right? Why do you have both the small one and a bigger one?
For different roles
What are the different roles?
One to handle thin or minimal objects, and other to handle tougher objects.
Why don't you use the tougher object for everything?
Tougher object for everything.
I mean, sorry, the tougher knife for everything.
Because it is not required.
It's not required,
won't
but why not use it?
It won't give precision.
Okay. Why won't the sharper thing and the bigger thing give you more precision? You may get precision out of it too.
Can I try?
Yeah.
It's because it's not developed for that purpose.
Why not? Why not? It's not developed for that purpose, but why not
Because
make-
we can't cut the vegetables with a sword. We have to use a
Why
knife,
not?
right?
Why
Because
not?
it's suitable. It's for that purpose. Knife is suitable, not sword.
Why not is my question.
Sir, the reason is that like
Suitability.
Why?
knife,
To
knife
handle
weighs around 20 grams, whereas sword around having half and 600 grams of weight. When you cutting that thing to that level, you use more power,
Correct. You need more power. So you want something which is more energy efficient.
more flexible, and you can say
Correct. In the same way, do you want to give the power of handling integers every time? No, right? Only when I know that I will definitely have to handle decimals, I will give that power. But in scenarios where I know I'm not going to handle decimals, why not stay humble and say, okay, this much is enough. Now, if I'm a computer and you're asking me to store a number, 4 zeros, 10 zeros followed by 1 and 1, are they the same or are they different? Ten zeros followed by 1 and just a 1, are they same or are they different?
like there are 10 zeros ahead of one.
10 zeros followed by 1 and just a 1. Okay, as a human, are they same or are they different for you?
same,
They are different.
It
For a
is.
computer,
It's
For a
different.
computer, it's different.
different.
because a computer is supposed to remember that.
Yes.
The computer is supposed to allocate memory for it. Now, so does a computer then allocate unlimited number of cells because you can have unlimited number of digits? No, right? You have to stop it somewhere. Now, let us say you're asking the computer to remember which floor of the building it is. Do you want your computer to remember 3 digits?
No.
If you are in some Burj Khalifa or something, you may have to. But otherwise, 2 digits are good enough, right? So you just dedicate 2 digits for it. So would you want to put a cap on how many digits you allocate?
Yes.
You would have to, because if you don't put a cap on the number of digits, it just goes on forever. Because for a computer, it's different. For humans, it's different. Humans can creatively spot the patterns and understand. Computers can't. So then for a computer, you have all those different sides of data types, right? So now you said there are data types. Now that is the Chatur Ramalingam way of learning things. But now when you look at it, you say, I have different kinds of information. So I want to handle them in a different way. Like as Deepak said, there's a knife and there's a, sword. So your longer numbers are probably like a sword and your shorter number is probably like a knife. So you have different data types because you understand that your information comes in different categories. And different programming languages come with different philosophies. So due to their philosophies, their data types might partially change in terms of how they want to look at information. Okay, so now we understand data types. Data types exist because the way we want to treat information changes. Okay, so through data types, you're able to tell the computer, please allocate this much of memory. Now, when you're doing normal computation, when you're writing a small program as a 7th class boy or an 8th class boy or something, it's okay if you consume too much memory, right? Especially if you're running one i5 or i7 or something. Forget i5, even if you're running a Pentium, it's okay if you consume too much of memory. It's not going to consume too much of memory. But let us say you're running a large simulation. You work in a biology research institute and you're running a large simulation over 1 million animals and you're trying to see how those 1 million animals are going to live in an ecosystem. What happens when you allocate too much of memory there? It's a problem, right? Your resources are getting wasted. So the way you manage your memory becomes important. In scientific computation, if you're running large computation, or if a lot of users are going to use it, maybe you have lesser computation, but a lot of users are going to use it. There you want to handle your memory very carefully. So, because when you're telling that, hey, declare this variable, you're basically allocating some memory. Now, what happens if you go and declare a variable inside a loop? You're dead. Those many times the memory is going to get allocated, and a lot of senior developers also make this mistake. So there's a reason why it's important to understand these things from the fundamentals. Because if you learn it like Chatur Ramalingam, you just accept it as a rule. And when there's a situation which opens up before you, you do not know how to handle that situation. So now we go back to the fundamentals. We say, when we want to give this program more power than say calculator, we start with giving it the power of a calculator. We say we want it to remember information. There we say that the kinds of information can change. So that way we manage our memory more efficiently. So we declare a variable. The moment we declare a variable and tell that this variable is of this kind, it's important to tell which kind that variable is, because when I tell which kind that variable is, my program can allocate the memory accordingly. But interestingly, if I'm not wrong, I think in Python you don't have to tell. Now, what is the question you would ask if I tell you that in Python you don't have to tell which kind of a variable it is? What's the question to ask?
How does it automatically detect which type of variable?
That a question which I would ask is that then why is C++ asking me to tell? When I say C++ is asking me to tell because it has to decide how much memory to allocate, how to allocate, and all of that. So then this answer. No, but Python is not asking. So now JS question comes. How is Python deciding? So Python is like dynamically adapting, right? It's adjusting. It probably believes that you're based on what value you give it, it understands, okay, this thing is like how humans understand. Now that's where Python is different from C++, right? Python is closer to human beings. C++ is closer to the machine. How do we humans understand that information, how to allocate? We look at it 5.0 or year decimal. So Python is trying to adjust. Now, what is the problem when your computer is trying to adjust to you? Okay, what's the problem with your autocorrect on your phone?
Slow.
No. What's the problem with autocorrect on your phone?
It corrects unnecessary items.
Sorry, Harshali?
It corrects unnecessary items that you don't want it to correct.
Yeah, unnecessarily, or sometimes the correction is wrong.
Yeah.
Sometimes maybe correction is required, but it's wrong. Or sometimes correction is not required and it does it. So it is quite possible that your automation can go wrong. So while in C++ you're fine because you're going with the rules. In Python, while you're handling data types, you've got to be careful because Python is trying to autocorrect there. You get the problems with being a higher level programming language. It's kind of like autocorrect on your phone. So you have to understand that it has its own mechanisms. And so now when you want Python to know that it's a string, what do? You give it in quotes, right? So that it doesn't get confused that this 0 is not a number, but this 0 is a string. Because that's where Python gets confused. It's a bouncer for Python. You tell a 0, is this a word called 0 or is this a number called 0? So there you try to play it smart because you want Python to not get confused by it. Okay. So, okay, the memory allocation, variable assignment, all of this is done. Now you also define your basic operations, right? So because your calculator has basic operations, so you want your Python also to know the basic operations. So there you give your number operations, you give your advanced scientific operations. Python has a fantastic scientific library. And you also want Python to be able to process words, right? And in 21st century, that is even more interesting because we're trying to process language as well. We're trying to, do things with language as well, right? So NLP and all these fantastic technologies have sort of come in. So that's when your concatenate and all these kind of operations which apply on your strings as well. So now we've seen how it would remember information and how it would act on information. So what does a calculator do? A calculator can remember information, it has memory, and calculator has operators. Now, when you talk of operators, there are certain operators which act on only one input. There are operators which can act on two inputs, and there are operators which can act on multiple inputs. So you have your operators defined, you have your memory defined. So that's the foundation of any programming language, right? But again, the way the programming language would handle it would change based on its philosophy. For example, if you look at Lisp does a lot of textual processing. So probably equips you with more tools to handle strings and so on. So depending on the philosophy of the language, or as we said, between C and Python, C is closer to the machine, while Python is closer to the human. So based on the philosophy, how the language does different things would change. So when you're studying a new programming language, it makes sense to study the history of it, to study the motivation of why they started it. So a lot of things make sense. For example, if you're studying JavaScript, JavaScript is a language which I think was made in less than 20 days or less than 25 days because they wanted, somebody launched something else and these guys wanted to counter that. So they had very few days to make it. So JavaScript till today is a very messy programming language because it is not done properly. So you have a lot of issues with JavaScript due to that. So now when you understand the history of your programming language, so the behavior of the programming language presents itself to you. So before you study any programming language, I would always advise you to study the historical context of why that language came out, who brought it out, and so on. Because then I think the patterns in that language, the features of that language, the syntax of that language becomes more intuitive to you. You know why they would have done what they would have, done. Okay. So now operators done, data types done. So let's move into our first piece, which we said. We said when we define something such as a programming language, we want it to handle repetition. So that I don't have to, let's say I have a machine and I want it to cut like 100 bread slices. If I have to program it, I'll say, okay, 100 times just cut the same damn thing. So I can just go give it the instruction, walk in my garden and come back, and by then all the bread slices are cut. So you want repetition. Now, when you want repetition, how does a computer know when to stop?
If the condition fulfills, then it will basically stop on its own.
Okay, one way is to say if all the bread slices are over, stop cutting. What could be the other way?
We can tell it to stop, like we can.
But it will keep going on until you tell it to stop. That's a problem, right? If that machine keeps going on forever. So wait, so do you want the machine to go on forever, or do you want to tell the machine that if this happens, you have to stop? Do you want to give a criteria so that the machine is forced to stop? It's dangerous if the machine goes on forever, right? So you want a mechanism where the machine stops. So one way is to tell the machine if this condition is met, you stop. Yeah, Harshali, you were saying something.
Yeah, just that condition could be this repetition multiplied by, for example, 4 number of times.
Exactly. So you can say the number of times it has to work. So one way is to say the number of times, and one way is to say that, hey, if this condition is met, you please stop. So you'd want your programming language to, sort of work that way. So then no wonder, right? We've got two kinds of loops. One which you call a for loop, where you say that, okay, there's a predictability in terms of how many times it's going to run or when it's going to stop. Or you have another fellow called a while loop, where you don't know how many times it's going to run, but you know when it's going to stop. Now, again, the Chatur Ramalingam way of learning it is this is used for this, this is used for this. But the research way of learning it is Python doesn't exist, C++ doesn't exist. I am creating that language right now. So how would I create it? You arrive at the concept. You don't learn the concept. This is research-oriented way of learning. So so you're saying, hey, I need loops. I mean, you're saying, hey, I want my program to be able to repeat it again and again. But then this fellow has to know when to stop. So how do I tell this fellow when to stop? One way is to tell this fellow that, hey, you've got to stop after these many times. You're out of fuel. Or another way is to say, hey, you've reached your destination right now. So stop now. Where you have a condition. So you have your for loop and you have a while loop has two mechanisms to implement automation. Now, let us say you have a onion and you have a tomato and you're cutting both with the same knife. Is your method the same or is your method different?
Method could be same, but the force could be different.
Your method changes a bit, right? Now, you cut the onion in the same way you cut a tomato. Do you cut a tomato with a lot of force?
No, that's what I said, right? Force could be changed.
Force, okay, you said force, okay.
Or we can't peel the tomato, but
Right.
we could peel onion.
If the knife is sharp, the method is same itself.
Sorry?
If the knife is sharp enough for both or any vegetable, the method is same.
But you cut the tomato like how you cut the onion. Your method of cutting changes, right? You don't cut the tomato into little cuboids of sort, right?
Yes.
Yeah, I do.
Yes, it is different.
Oh, you do? Okay, that's interesting.
It depends.
Okay.
Yeah, actually depends, but try to cut it if the destination is trying to cut it in the very small cubes, then the method is same.
Yeah, but usually that's not the destination, right? Or that's not the goal.
Very rightly said. Like the
Sorry?
force, it depends on the force. Like the force of cutting changes.
No, but as Amrita said, what if the knife is like really is super sharp?
Regardless, the feel when you're cutting a tomato versus the feel when
Correct.
you're cutting an orange will be different.
Correct. So
Sorry,
now-
an onion, my bad.
Yeah. So now if you're in Mumbai and you're going to Delhi, you're in Mumbai and you're going to Thane, you're in Mumbai and you're going to New York, would your mode of transportation be the same? So we as humans, do we have this way of thinking all the time? Situation-based thinking? Our decision changes based on the situation. So do we want our program also to think that way? So what do we need?
Exception handling.
Conditions. If this happens, please do this. Otherwise, you do this. No, do you have only this condition? If this happens, do this. Otherwise, do this. Is this the only kind of mechanism we use in life?
No.
No.
We might also have different possibilities, no? If this, otherwise, okay, this. That's where you have your if, else, and all of that, right? So now okay, let's ask ourselves a simple question. Forget programming languages for a while. Let's look at human languages. Now, all languages have different words, all languages have different concepts. But what is common to all languages?
Sign language.
No, I mean all languages, like say Telugu, Tamil, Malayalam, Kannada, Marathi, Gujarati, Hindi, all of them, what's common to all of them?
They have a grammar.
Right?
They all are speak and
They all have
write.
nouns, they all have nouns, they all have verbs. Because you require those basic functionalities for a language. Because you want to be describing people, you want to be describing the doers of action, you want to be describing the receivers of action, you want to be describing action. So no matter what language you're talking of, most languages you tend to see nouns and verbs. So whatever is a fundamental need, you tend to see that across all languages. Now, in the same way, whatever is a fundamental requirement, you tend to see that in all programming languages. You see, loops are a very fundamental requirement. Why are loops a very fundamental requirement?
Because
Repetition.
Yeah, there are a lot of scenarios where you want to repeat the same logic. So again, those loops have two different, ways of stopping, right? The stopping criteria. One is after a destination, another is based on a condition. Now, when you look at conditions, even that is a very fundamental requirement, right? Because based on the situation, we want a program to execute. Now, in real life scenarios, are the scenarios that kind to us that we just write 3 conditions and it's done? Okay, I want you to tell me a method through which from here, wherever I'm sitting, I'm supposed to go out, I'm supposed to buy some tomatoes and come back. What is your method? You have to tell me a program. You don't know anything about me. Your program has to function irrespective of my conditions here. What's the first step you tell me?
You have to stand up.
Stand up. Okay. Do you just say you have to stand up or there's a condition there?
If you are sitting, then
If you're
stand up.
sitting, then stand up.
And
If I'm sitting, are you sure you want me to stand up or one more condition?
If you find the shop.
no,
and
first of
buy.
all, you have a money. You need a money to buy.
But I still have to stand up, right? Okay, you're saying, okay, if you're sitting, you stand up, I stand up. And you say, if you have money, go out. If you don't have money, take money. Then
If you don't need to stand up, if you remember, if you already have a tomato at your home or room, there is no need of standing up there.
okay, that's a good question. Do you already have tomatoes at home? Okay, now, okay. After that, I stood up. I have money in my pocket. Next, what? Is it go out?
Vehicle, like, yeah, go out and
No, if your door is not open, open it.
open.
yeah,
If your gate is not open, open it. Take your vehicle out. If nobody else is going to close the door, close the gate, you close the gate.
No, first have your sleepers.
Yeah. So you see, there's a combination of conditions that come in real world. So that's where, logic gets interesting, that we combine loops, conditions, and all of them. But what we've got to understand is when we do programming, we're having just these basic anatomic elements. It's like you go to Subway, the guy has paneer, the guy has the bread, the guy has got, mushroom and a few things. You ask whatever you want, it's just the same things being combined in a different way. So you look at programming, you might feel in computer programming, there are a lot of concepts. But if you think about it, it is just these fundamental commonsensical concepts. That, hey, I need a way to make this thing repeat. I need a way to impart situational wisdom to my computer, where my computer changes its approach based on the, situation. So as long as I can combine the situations and loops, a lot of things get done. Okay. So this is what I have for today. But we will have a discussion on data structures, sometime soon. And there as well, the question to ask is, today we discuss memory. So there, how do we want to manage the memory becomes an important question. One is how much memory are you using? Second is the way you use the memory can change how fast you are in reacting. For example, if I have a lot of books in my house, I want to organize them in a certain manner that whenever I need a book, I pop the right book out at the right time. So the way you store your things has a huge influence on how well your program works. So that's where your data structures as a concept, sort of comes in. And then now you know how to write these basic blocks of logic. But then there could be very efficient ways of writing these blocks of logic. Those are your algorithms. You could use one method, could use another method, but one method could be way faster than the other method. Now, how do you handle all this information? You have your data structures, different ways of handling all that information. And what methods you use, that's algorithms. Now, be it data structures or algorithms, you implement them using basic programming. So I think you can then break it down to basic programming, data structures, algorithms. If you know these three, rest of it, Stack Overflow anyway exists. Now you have ChatGPT also. So, but what is important is to understand these three, because these are not things that you can, delegate. Because you need to understand these three to even ask a question to ChatGPT or to search on Stack Overflow. So, because now with the age of AI, what you need is strong fundamentals, strong thinking capabilities, because rest of it the AI will do. So today, what did we do? We spoke about beating a calculator, because the calculator cannot repeat things, calculator cannot handle some of the complex logic. Then we said to beat a calculator, we'll first start with what a calculator can do. We'll start with how we store information, how we do these operations on information. Now, when we spoke of storing information, we said different information is of different kind. And we, using the example of Deepak, I guess, right? The sword and the knife, such a beautiful example. We saw that, okay, everything has to be handled differently. And we saw the concept of data types. Then we said, when we want things to repeat again and again, there has to be a halt criteria or a stopping criteria. Then we saw two kinds of stopping criteria, one which goes on again and again. Other criteria we saw is conditional, that is your for and, while. And then we saw that in reality, we use a lot of situation-based approach. So that's where your conditional statements sort of come into, picture. So these, I believe, are the most fundamental things. If there are more, which we'll probably discuss in the next few sessions, and we'll also be discussing data structures and algorithms. But today, I've purposefully not done much, because my intention in the first session is to expose you to a new way of looking at programming. So I'd love to hear your reflections. What are your thoughts and what are your realizations at the end of this session? I'd love to hear from you guys.
I would like to go.
Yeah, Harshali.
My reason to attend this was to understand how data plays into role of any data scientist or data analyst. I was trying to understand. I come from non-tech background, so I'm trying to understand um, where it all plays into action, and you explained it in very simpler terms. Trying to so now what I've gotten from this is trying to break things into very small things, and try to take it down into layman terms. It would be very helpful for me. So this is what huge thing I got from this, and I would very much like to take it forward and try to understand more. And now it's just given me an interest to dig deeper into data science. So thank you very much for that.
So, Harshali, we have a worksheet at Deep Thought. We have a worksheet. So, in that worksheet, what we do is we give you a program and we ask you to write subtitles for that program. So, one very nice way to master programming, or say any kind of software development and so on, is for all your code, you can write the subtitles in the right, your comments. And when you write your comments, can you make it as intuitive as cutting vegetables or storing information? I mean, like how the kind of examples we use today. Because our mind is more used to those intuitive examples than the formal. See, there are formal objects and there are empirical objects. Formal objects are the objects which are defined in mathematics or defined in computer science, which are very carefully, rigorously defined. Empirical objects are the objects in your experience.
Okay.
Like a tomato or a potato, and all of that are in your experience. So for every formal object, if you can draw a correspondence with an empirical object, that can help you understand formal objects better.
Okay.
Now, this is a topic from philosophy of science. Maybe someday when we have a workshop with this, I'll be explaining what is a formal object, what is an empirical object, and how you map them. But I think one area where I see people having challenges with mathematics or computer science is because these are formal objects and they're not intuitive.
Yeah.
There's a way to handle them. That way to handle them is to make that correspondence between that formal object and that empirical object.
Yes. I've kind of found that in this session only.
Yeah.
Thank you so much.
Yeah. Thank you, Harshali. Who wants to go in next?
I'll go in.
Yeah.
So it was actually a very brilliant session, and it like the whole concept of you explaining the for loops, the conditional statements, the various types of data types. It was really something that I never ever happened to come across, and it was pretty unique. I would, like Harshali said, like I would be really happy to be a part of the sessions coming through this week.
Sure. Thank you, Rishabh. But yeah, anyone who goes in with what were your takeaways or what were your realizations? Yeah, Anuj.
Yeah. So actually, as a programming, I have a programming background, so I know all the technical aspect. But I am here because I know that you are taking this workshop and you just present it in a very different manner. Like I have never heard this before to connect it with a real life examples. Like so, that is my takeaway.
As I said, formal empirical object.
Formal and empirical object.
Yeah. Thank you, Anuj. Who's going in next?
I'm coming. So as Anuj said that I also from a programming background and I know all of that, but I know that from a chatur kind of background. You can say, okay, this is for loop, this is while loop, this is how it's working, kind of that. The only reason to attend this Python workshop is first is you, because you are hosting this. I know one thing about you, that you can host whatever you host, and maybe I'm expert in that subject. You digging me some new things, which I can, oh, maybe it can happen. Oh, you can create new insight. You can go deep down in that thing. And second is I never, you can never relate in that in my practical field. Like, okay, I'm going to buy tomato. I never seen it with that perspective, with that approach.
Okay. So I think Deepak, the more you practice the Socratic traditions of learning and Feynman's approach of learning, the more you practice these traditions, I think you start connecting more and more with the fundamentals.
Exactly.
And you get access to power. Fundamentals are power. You have the ability to face more situations when you have that access to power. And I'm glad you're showing interest in this, and I hope you will pursue more of this approach of learning.
Yeah, one thing is more that you say DSA. I like many of my friends say that DSA is very hard. You can that you if you try to learn DSA, it will take around 1 year, around 1.5 to master in that. But when you tell me that how to, you can say how to store data in that format so that you can pop out things easily. And for that you have to write an algorithm. Then I got connected. Oh yeah, well, this thing I have to do. This only thing I have to become expert in just basics. Okay, what are these? What I have to doing with? Like, why do I doing this? Main thing is that I think you're not getting my point. Yeah, either I'm not explaining well in that, but I want to.
But I get your point. So I think, Deepak, it's very important to know the purpose of anything, right? Like today when we spoke of loops, we saw the purpose of the loop and then went into the loop. So every concept which comes out, right, there's a motivation for that concept. So, okay, when we study in a research institute, right, where I went to, I mean, ICER and IMSC, where I did my research project, the way our professors introduce concepts to us is first we discuss the motivation. Then the concept comes out. So when you discuss the motivation and then bring up the concept, it's like you believe that the concept doesn't exist. You start debating it and then you arrive at it. It's as though Indian constitution doesn't exist and you're Ambedkar and you're the one with your team, you're bringing out the constitution. So you're going ahead and defining your own concept. So seeing the purpose of the motivation of the concept and then seeing the concept, I think is a very powerful way of learning. That will help you take the same idea to more places. Okay. Anyone else wants to go in with your observation?
Yeah, Tarun, even I'm from a technical background, and I've learned many program languages by usually others do in YouTube, in Geeks for Geeks, W3 schools, etc. Very technical way, and if there is an innovative way also, it will come down to the same thing, I think. But this is very different, and how the expectations are set by research based learning is very effective, and we can easily relate these with whatever we learn, like any other programming languages or scripting languages by that chance. It will be effective in memorizing or relating it to what we actually do and take it in practical way. So thanks for that. And I had another question. It was a technical question. In for loops or any kind of loops, when there is no condition and it goes to infinite loop, how the memory is managed there? If by just exiting the console, will that memory gets erased by itself, or how that is handled? How can it get erased when it has gone to an infinite loop for that long time and the memory is been emptied?
So, I mean, I'm not an expert on operating systems or these concepts to understand. I mean, I'm more of a theoretical computer science guy.
Okay.
So, I may not be the right person to answer this question, but let me take a shot at it. See, one thing I know is that when you declare a variable and you've come out of that program, so that variable is no longer active, but that value that you assigned there still lives there. Do I make sense?
Yeah.
The value still lives there, but that variable is not there. But if you don't flush the memory, what happens is it is quite possible that you might read that old data which is already there. So I'm guessing it has something to do with this, that you flush the memory or something like that, right? Because you tend to reuse the memory again.
Yes, but if only once that loop is exited by hard exiting or hard quitting the console or that loop, how can that get flushed, like the flush entire variable or the data which is assigned to that variable?
That's a very good
Because
question. Let me.
it has taken a long time to do that infinite loop itself.
That's a good question. I'll hopefully find that out and bring up this answer in the next session.
Yeah, you can think about it.
But just thinking of some ChatGPT prompts for this.
Sure.
So one
As I learned yesterday.
one ChatGPT prompt for this is to find out how are those loops hard closed, and if they're hard closed, what happens next? So I think these are some questions I would like to ask ChatGPT and understand again the fundamentals of how a computer actually does this memory management.
Yeah, memory management and OS also. Yeah, I'll learn about it.
Great.
Thank you.
So I would like to conclude this session by sharing something with you guys, which is we may be learning any subject in this world, but end of the day, we've got to understand we're humans and there's a way we behave because we're humans. And the moment you can humanize your subject, you can master that subject. The moment you can bring that subject into a format which is very conducive for humans, you can master that subject. So when I say formal, empirical, and all of that, or through questioning, this is how we humans like to learn. And when you can humanize a subject, you don't have to try to memorize it. You tend to remember it. Because we humans have a good memory. The only thing is we've got to figure out how we feed it to ourselves so that we internalize it. So this is what I would like to sign off with. And in the next session, hopefully I'll pick up some more topics. And my idea is to cover all the basic concepts of Python just within the next 3 to 4 sessions, so that anybody who wants to learn Python just accesses this 4 or 5 recordings and can complete the basic concepts. So if you try to memorize things, you try to learn the Chatur Ramalingam way, it takes too long. But you try to see it conceptually and you do a lot of practice, you won't take too long to get comfortable with Python. And probably learning Python is a lot easier than C++ because Python is a lot more liberal. But yes, learning C++ could be fantastic because it forces you to do a lot of thinking, which Python may not force you to think, because C++ is more rigorous in how they want you to specify things as opposed to Python. So that's it for now, and thank you everyone for joining.